So, good morning, student. Today, I will prove the Heron's theorem in detail. But you are thinking that why I will prove Heron's theorem again? Because on my Heron's theorem proof was my first video in You Will Love Math. But at the time, the setup of my teaching room or my classroom was not that much good. Light was insufficient, so some of my student or some of my subscriber has told me to show that theorem again, so that it will be they will understand in a better way, they will understand in a good way. So for you are watching You Will Love Math for beautiful mathematical problem solving, mathematical concept and learning. You are here in You Will Love Math. So first, what I will do, I will do I will prove the Heron's theorem by geometry, classical Euclidean geometry. And another proof we can do in by trigonometry, which is in class 11. But in trigonometry is a powerful weapon, powerful tool of mathematics. So for that, using a powerful tool, a complex problem can be solved easily. But using a elementary tool, if you can prove a good problem, a complex problem, then it's the it is the rich mathematics. Okay, so now I will prove again Heron's theorem, Heron's formula, which is s into s minus a, s minus square root of s into s minus a, s minus b, s minus c. So I am proving it again. Those who missed my first video, that video was something lagging in light, or any, if the visibility, if there is any visibility issue, so I am proving this once again. So keep learning with me, keep doing problem solving with me, and keep watching. You will love that. So first, the what is Heron's theorem? Heron's theorem is basically, if I have any triangle like a, b and c. So opposite of A we can write small a, opposite of B we can write small b, opposite of C we can write small c. So now what Heron's has told, Heron's theorem, what Heron's have told, Heron's have told that, or proved that, the area of that triangle will be square root of s into s minus a, s minus b, s minus into s minus c. So s into s minus b, s minus a, s minus s into s minus a, s minus b, s minus c. Fine. So Heron says, so how can we prove it? We can prove it very easily. So first, draw a triangle properly, and we will use here, basically two important theorem. What are those? Pythagoras theorem, Pythagoras theorem an important theorem of algebra, which is a square minus b square equals to a plus b into a minus b. Okay, so Pythagoras theorem and this theorem. So now, in what I can prove in Heron's theorem or Heron's formula. So draw a triangle here, because the diagram is not much necessary, but it is important, necessary. But why I am writing at the top, or right top, because once I draw, then I don't need it, only I will look at the diagram and solve the problem. This is an art of problem solving in board, because when the diagram is not that much, you are not needing the diagram by doing something, so do it at the right top or left top. Okay, so now do a scalene triangle first. For any triangle, Heron's theorem is applicable, but we will prove a scalene. Then, if any sides are equal, then A equals to B or B equals to C or A equals to C, anything, or if all are equal, then also Heron's formula is applicable. Sorry. So now it's A, it's B, it's C. Now opposite of A, opposite of B, B, opposite of C, C, small c, all. So now what we will do, we will do we will draw, or another theorem is, another important theorem is required. Area of any triangle equals to half into base into height. Those three theorems are required. So now we will draw a perpendicular from A to BC. It is H. Let name it D. Fine. So now we will prove one by one. Okay. So from triangle ABC, what we are getting? From triangle ABC, area of ABC is half into base into height. Fine. And if we assume BD is X, then DC will be A minus X. Fine, because BC is A. So now in triangle ABD, using Pythagoras theorem, this since it's a perpendicular, so both angle is 90 degree. So for in ABD, from Pythagoras theorem, what we can write? A square plus X square equals to C square. Fine. And in triangle ADC, what we can write? A square plus A minus X whole square equals to B square. Fine. So keep, this is 2, this is 1. Fine. Now from here we can write A square equals to B square minus A minus X whole square. From this we can write A square equals to C square minus X square. Fine. Fine. Now if A square are both the values, we can equate these two values. So main important part we are deep diving. We are deep diving in the main important part. Now B square minus A minus X whole square equals to C square minus X square. Fine. Now B square minus, we can A square, we can do A minus B whole square. So another important thing will be, we can use A minus B whole square formula equals to A square minus 2AB plus B square. So I am noting it down so that you will understand more easily. So A square minus 2AX plus X square, C square minus X square. Fine. Up to now it's clear? Yes. So now what will be the thing? B square minus A square plus 2AX minus X square equals to C square minus X square. Fine. Now cancel out X square and X square. So what we can write from here? Keep 2AX one side, and the side value we will place another side, or I will place 2AX in the left hand side, or the side value with the right hand side. Okay, so 2AX equals to C square plus A square minus B square. So X will be, keep in mind, C square plus A square minus B square by 2A. So it's an important thing. So what we will get? We will get from here X equals to C square plus A square minus B square by 2A. Fine. So if we place the value of X here, so what we will get? So I am erasing it. Hope you have noted down. So I am erasing it. Okay. So this I am erasing. This part I am erasing. Okay. So now Now the thing will be now the thing will be a square plus x square. From here a square plus x square equals to c square. Fine. So I am from the diagram a b d. Fine. Now what we are getting a square x square, what we are getting x square, x square we are getting c square plus a square minus b square by 2a. Fine. So we are getting this c square. So now what we will do, a square equals to c square minus c square plus a square minus b square by 2a whole square. We can place from this value from left hand side to right hand side by minus. So a square will be, I can do use this formula, a square minus b square. So what will be the thing, c plus c square plus a square minus b square by 2a, and again c square, c plus c square plus a square minus b square by 2a. Okay. So now what will be the thing, 2ac, I am doing LCM, 2a, c square plus a square minus b square by 2a, again 2ac plus c square plus a square minus b square by 2a. So very easy. Now a square plus 2ab plus b square. Hope you are understanding. This is formula of c plus a whole square. Make a third bracket. Now minus b square by 2a. Fine. Into so c plus, sorry, both are not plus, sorry. So 2ac, so 2ac minus c square minus a square plus b square. So there was a mistake, both are not plus, this is minus. Fine. So 2ac minus c square minus a square. Why will be minus? Because minus is in front of that value. So the minus value will be in front of c square, in front of a square, and when it will be minus 1 will be multiplied with b square minus b square, it will be plus b square. Fine. So now I can write b square, I have taken minus common again, c square plus a square plus 2ac. Fine. Sorry, minus 2ac. Fine. Why? Because in front of 2ac it is plus. So by 2a, again we can write from here b square minus, so again we can write from here b square minus c minus a whole square from here. I hope you understood. For the first thing I am writing. So what we are getting, basically we got from here that a square equals to c plus a whole square minus b square by 2a, and b square minus c minus a whole square by 2a. For better understanding, give a third bracket. Fine. So I can write, I can erase it. So a square we have got this one. Understood? So now a square equals to, again we can write, use this formula, a square minus b square formula. Okay. So c plus a plus b, c plus a minus b for the by 2a, and for that term what we can write, b plus c minus a, b minus c plus a by 2a. Fine. So for this term, this is the expansion, and for this term, this is the expansion. So now what we can write? 2s a c plus a plus b, and c plus 2a equals to 2s minus b. Is it clear to you or not clear to you? Is it clear? Yes. How if not clear, a plus b plus c equals to 2s. Fine. So c plus a, sorry, b c plus a, we can write 2s minus b. So I am using these two. Fine. So c plus a, I can write 2s minus b, and minus b is present. For b plus c, we can write again 2s minus a, and b plus a minus c means 2s minus c minus c. Fine. And for this we can write by 2a. For this we can write by 2a. Fine. So now 2s into 2 into s minus b into 2 into s minus a into 2 into s minus c. Fine. By 2a, by 2a. Fine. So 2 2 we can cancel out, 1 2, and 1 2 we can cancel out. So what we are getting? 4 2 2 will be remaining at the top. So s into s minus a, s minus b, s minus c by a square. So h square we are getting 4 into s into s minus a, s minus b, s minus c by a square. Fine. So now what will be the h? H will be square root of this one, square root of this one. H we can write square root of this one. So what the thing will be? We can take out from the root 2, instead of 4 we can write 2 square. That means 4, we can, the square root of 4 is 2. So in the top we can write 2 from outside of the root, and for the a square we can write outside of the root a, and whole thing will be in root. Fine. Now we are approaching to the result. The Heron's theorem, the great theorem of classical geometry, not classical geometry, in geometry and in trigonometry also, and it's a milestone. It's a milestone. So and one milestone is also Pythagoras theorem. So now what we are getting? We are getting basically, I am erasing it. We are getting basically h equals to 2 by a square root of s into s minus a, s minus b, s minus c. Fine. Now what will be the area of ABC? The area of ABC will be half into h into a. This is the ABC, or half into h into BC, half into h into a. Fine. Very easy. Now put the value of h, the problem is solved. Half into 2 by a square root of s into s minus a, s minus b, s minus c into a. So for a you can cancel out, 2 2 you can cancel out. The area is square root of s into s minus a, s minus b, and s minus c. So the Heron's theorem is proved. A gem theorem of mathematics is proved. So thank you for today's class learning with me, and you have learned a beautiful theorem, a marvelous theorem, a gem of classical geometry in Euclidean geometry, using only these two theorems of geometry and these two theorem or these two formula of algebra. So thank you for watching, thank you for learning, and if you think that this is useful for you, so please share this video to others who want to learn mathematics, who want to do mathematics well. So thank you for today's class.